Okay, everyone, assalamu alaikum. Let's begin. So we were doing functions, and in the last couple of sessions, we have talked about a number of things. So we started with this. We started with function notation. Then we talked about domain and range of functions. Domain is basically the set of values of x that you can input into a function, and range is the set of values of y that a function can give you as an output. Then we talked about range of linear functions. And for any other one-to-one function, all you have to do is just look at the endpoints, and you can find the range. For linear functions. You can actually sketch the graph and try to understand from the graph what the range looks like. We talked about range of quadratic functions. That's the most important one because it's the one that's tested most frequently. We talked about this, how changing the domain of the quadratic function gives us different range every time. So we looked at a number of examples of this where we looked at the same expression, as in the same function, where the domains were different, and we saw how each of those different examples was giving us a different set of values for the range of the function, right? So for quadratic functions and for any function in general, we said we would be looking at 2 points when we're looking for the range of the function. One, endpoints of the domain, and the second thing, turning points of the domain. Okay, that's what we talked about. Then we talked about the range of reciprocal functions or rational functions. For this, we said in your syllabus, you will only have those rational functions which do not have any turning points. Okay, in that case, all you have to do is just look at what happens at the extreme values of the domain. So if x greater than 0, we looked at what happens at 0, what happens at infinity, and there were a number of examples that we did for reciprocal functions as well. Okay. In the last session, we talked about these different types of relations that you can have: one-to-one, many-to-one, one-to-many, many-to-many. And we basically concluded that only the first two types are called mathematical functions. When you have a one-to-one relation or a many-to-one relation, these are the ones that are called mathematical functions. So in order to be a mathematical function, in order to be defined as a mathematical function, a relation can only have one single output. The output should be singular, okay? So output has to be one. You could have one input or multiple inputs. That is possible, but the output has to be one. So only one-to-one and many-to-one relationships can be classified as functions. All right, that's what we talked about. Then out of these two, we said only one-to-one functions have inverse, because if you were to reverse many-to-one, what would happen? You would end up getting one-to-many, right? Since the domain and range interchange, since the input and output, they reverse when we find an inverse, since they interchange. Inverse of one-to-one would also be one-to-one. However, when you find inverse of many-to-one, that is going to become one-to-many, and one-to-many is not a function. So we say inverse for many-to-one functions, therefore, does not exist. Inverse only exists for one-to-one functions, because when you inverse one-to-one, that still gives you one-to-one, and that's also a function. Inversing many-to-one gives you one-to-many, which is not a function. So we will say inverse only exists for one-to-one functions. Now, that's something that you need to remember. We talked about horizontal line test, how you can look at a graph and figure out whether that function is one-to-one or not. Then we talked about inverse of functions, inverse of linear functions. This is something that you've done in O-levels as well. You know the process for this. We quickly revised that. And then these were some important relationships between a function and its inverse, that the domain of the original function is the same as the range of the inverse function, and the range of the original function is always the same as the domain of the inverse function. Okay, so that's the relationship between a function and its inverse. Since we interchange x and y when we're finding the inverse, domain and range, they also get interchanged because of that. Okay, so domain of f of x is range of f inverse of x. Domain or range of f of x is domain of f inverse of x. Okay, all right. Then we talked about sketching graphs. So this was one example that we did. If you have to sketch a graph of a function and the inverse of that function, you always use a square grid. That means same scale on both axes on your diagram. Whatever represents one unit on the horizontal axis, it should be the same on the vertical axis. And then when you draw these graphs, the graph would always be reflections of each other in y equals x. So a graph of f of x and f inverse of x, they're always reflection of each other in the line y equals x. And you will always draw this line y equals x as well when you're sketching graphs of inverse functions. You will always need to draw this line, because that shows you that they are reflections in this particular line. Okay, so you have to draw this y equals x line as well. This is what we did in the last session. Now today we want to start with inverse of quadratic functions, right? So that's the main concept that we want to do today. And then maybe we could have a look at a couple of questions from the worksheet. And then tomorrow we want to do the last major concept that we have in this topic, and that is composite functions. And then there's another section of function, that's function transformation. We'll also be doing that later on, most likely next week. Next week, by the way, we might have an extra class on Monday instead of Tuesday. Okay, so instead of Tuesday, we might have the night class on Monday, because Sunday and Tuesday and Thursday they might be odd nights, so we might not do classes on those nights. So we'll do classes on. We will most likely do an extra class on Monday next week. Okay, so instead of Tuesday, we will shift that to Monday. Okay, so now inverse of quadratic functions. So on Monday, we will talk about function transformations, and hopefully we can complete that concept on Monday and then maybe do some more practice questions on Tuesday. Okay, let's get back to this. Inverse of quadratic functions. How do you find inverse of quadratic functions? That's the first major thing that we want to do today. Let's say you have a function like this, f of x that equals x squared minus 2x plus 3. You've got this function, f of x equals x squared minus 2x plus 3. And you're supposed to find the inverse of this function. Now, how would you do that? It's a quadratic function. What does it look like? It's a U-shaped graph. The graph looks like this. Right? This is the graph of a quadratic function. What we want to do is we want to find the inverse of this quadratic function. Now that should make you think, because We just talked about this in the last session, that inverse only exists for one-to-one functions, right? We talked about this, that inverse only exists for one-to-one functions. Now we're talking about finding inverse of quadratic functions. Now this is a quadratic, this is what the graph of a quadratic function looks like. It's a curve, it has a turning point, and it fails the horizontal line test. If you were to draw this horizontal line, it cuts the graph at 2 points. That means at this point and at this point, you have the same y value for different values of x. So it's not a one-to-one function. So how can we find inverse of a quadratic function then? That's the question. Now, if you think about it, this whole function is not one-to-one. So we can't find the inverse of this whole function. What we can do, however, is we can define the range, define the domain of this function in such a way that it becomes one-to-one. Now, let me explain what that means. If you were to find the turning point of this function, how would you do that? Let's find the turning point of this function. X squared minus 2x plus 3. You could use differentiation, minus b over 2a, completing square, whatever you prefer. Let's say we use minus b over 2a, minus into minus 2 divided by 2 times 1. That gives us 2 over 2, which is 1. The x coordinate of the turning point, let's say this is the turning point, is 1. What about the corresponding y coordinate? Put this back in the function, x squared minus 2x plus 3. That becomes 1 whole squared minus 2 plus 3. And that's going to give us 2. So the turning point of this function is 1 and 2. Now, if you were to break this function down like this, that, for instance, you could have a domain like this. Let's say the domain of the function is x less than 0. X less than 0. Now, if that was the domain of the function, what part of this function would be valid? You could have 0 here somewhere. Let's say this is the x coordinate 0, y coordinate will be 3. Only this part will be valid, right? X less than 0 means only the left part of this curve is valid. Now, if you look at the yellow part only, that yellow part is one-to-one, right? That yellow part is one-to-one because in the yellow part, you can't draw any horizontal line that cuts the yellow part at 2 points, right? So the yellow part is one-to-one. So if we had the domain of this quadratic function, something like this, x squared minus 2x plus 3 with domain x less than 0, we could say it's a one-to-one function now, and then we could find the inverse of this function. Now, x less than 0 would make it one-to-one. Similarly, if you had x greater than or equal to 2, for instance, or maybe greater than or equal to 3, where would that be? It might be somewhere here, 0.3 with some y coordinate. And this part would be valid. This would also be one-to-one. All right. Similarly, you could also do something like this. You could say it's x less than 1 maybe, or even equal to 1. That would mean you're going all the way up to the turning point. Less than or equal to 1 means all of this region. This is also one-to-one. So basically, you could define the domain of the function in such a way that either only some part on the left is valid or only some part on the right is valid, because that will make this quadratic function one-to-one. Okay. So now, considering that it's a one-to-one function, let's assume that we were given this domain in the question, that they gave us that x is less than 0. Let's say they give us in the question that x is less than 0. Now, what we need to do is we need to find the inverse of this function. Now, how do you find inverse of this function? Let's think about this. Remember the process that we have for finding inverse? We will do exactly the same thing that we used to do for linear functions in the beginning, as in we will start by supposing y equal to f of x. Let's do that. In place of f of x, we put y, so it becomes y equals f of x. And now this becomes y equals x squared minus 2x plus 3. This is what we have. And now the problem is we want to make x the subject, right? That's how you find inverse of a function. You put y equal to f of x, then you make x the subject. But how do you make x the subject here? You have x squared minus 2x plus 3. Can you try making this a subject? What happens if you try to make it a subject in this form? You can keep x terms on one side. On the other side, you would have y minus 3. Now you could try taking x common, but that leaves you with x minus 2 inside. What do you do now? How can you make x the subject? It can't be made the subject in this form. Okay, you can try that and it will not work out. So how are we going to make x the subject? For making it the subject, we would first need to complete the square of this function. There's no other way of making x the subject. We would first need to complete the square of this function. Okay, we need to convert it to completed square form. Now, how do you do that? We have done that in quadratics. Coefficient of x square is already 1. Otherwise, we will take that common outside. In this case, it's already 1. So we say y equals x squared minus 2x. Leave some space. We have 3 at the end. Now, in the middle here, divide 2 by 2. That gives you 1. Square that. Add that number here. So you have plus 1 squared and also minus 1 squared. And now these first 3 terms are going to give you a perfect square. X minus 1. That gives us y equals x minus 1 whole squared. That's a perfect square. So from these 3 terms, you get the perfect square. And then outside, you have minus 1 plus 3. Let's simplify this. And that gives us y equal to x minus 1 whole squared plus 2. And now we can make x the subject. We could not do it before. Once we have completed the square for this expression, then we can make x the subject. So what do we do now? Let's take 2 to the other side. And that will give you x minus 1 whole squared equal to y minus 2. Take square root on both sides. But remember, whenever you take square root in an equation, what do you have to do? You have to put plus minus, right? Because it could be positive or negative. Both possibilities are there. So you put plus minus square root of y minus 2. Okay, so when you are taking square root, remember always to put plus minus there. Now, let's make x the subject. When you make x the subject, it gives you x equals 1 plus minus square root of y minus 2. And that's x made the subject. Okay, but now, we have not really considered until this point that only this left part of the function is valid until we had this x equal to 0 somewhere. Only this part of this function was valid in this case, right? This result that you have gotten here, the graph of this thing looks something like this. The graph of square root function with plus minus, it has a shape like this. Now, this is not even a function, right? Because it's one to many. One value of x here can give me this value of y, this value of y. It's not even a function. Why? Because we're considering the whole thing for now. Many to one, it becomes one to many. So just like we have only some part of this original function valid, we are only going to have some part of this inverse valid, which means only one of these plus or minus signs is going to be considered valid in this case. Because this upper part of the graph represents the case when you have plus here. And this lower part of the graph represents the case when you have minus here. You're either going to have plus here or minus, only one of them. So initially, when you take the square root, you're always going to have plus minus there. And then once you have done that, you will have to decide whether you are going to be using plus there and or minus there. Now, how are you going to decide that? Using the domain of this function. Now, we have made x the subject. And we are given in the question that x is supposed to be less than 0. That's what we're given in the question. The question says x is less than 0. Now think about it. You have 1 plus minus something. If you add something to 1, if you have 1 plus something, would you get something less than 0 or greater than 0? You would only get something greater than 0. When you add something to 1, 1 plus something, that's going to be greater than 0. All right, that's going to be always positive. It can never be negative. On the other hand, if you do 1 minus something, that does have a possibility of being less than 0. With plus sign, you have no possibility. With plus sign, you have no possibility of being less than 0. So looking at the domain of the original function, which was x less than 0, we decide that we should have a negative sign here. So we would write it as x equals 1 minus square root of y minus 2. And then you do that last thing that you used to do, replace x with f inverse of x. And on the right side, in place of y, you have x. This is what the inverse function turns out to be. F inverse of x is equal to 1 minus square root of x minus 2. This is the process for finding inverse of quadratic functions. Okay. So let me write down the steps that you have to do for this. What's the first thing you do? You always have to complete the square first. Okay. So the first thing you do is you complete the square. Because otherwise you would not be able to make x the subject. Okay, so if you have a general quadratic function like this, you would first need to complete its square. That's what we did here. Once you have completed the square, you make x the subject. Now, of course, before this, you have to let y equals f of x. That's kind of obvious. Let me write that here as well. Let y equals f of x. You complete the square after that. And then you make x the subject. Now, when you do this, do not forget to put plus minus with the square root sign. Okay, so until this point, you'll have a form like this when you have plus minus something. Okay, and then you need to decide whether to put plus or minus. How would you do that? You would use the domain of the function, domain of this original function, because you have x equal to something and the question says x is less than 0. Based on that, you decide whether you should put a plus sign there or a minus sign there. So in this case, we said it should have been a negative sign, a minus sign, because that is what can give us x less than 0. Okay, so what's the last thing you do? You say use the given domain of the function to decide whether to put plus or minus in the final result. So use the domain of the function to decide between this positive and negative signs. This is important. The rest of the process is kind of straightforward. A lot of times students forget choosing between plus minus and they just put plus there, thinking it should always be positive. No, you have to put plus minus there and then decide between the two, which one of the two is going to be positive. Is that okay to everyone? Any problem with this?
No, sir.
No? Okay, now let's have a look at one question on quadratic functions quickly from the worksheet. And maybe a couple. Let's start with one of them that basically tests a number of these concepts that we have done until now. Yeah, functions worksheet, it's uploaded, and you have questions assigned from that. Please make sure that you start working on those questions. Okay, let's try this one. This is question number 27 from the worksheet. Now, this tests a number of concepts that we've done until now. It's a 12-mark question, 5 parts. Let's have a look at this. Okay, so it says functions f and g are defined by these two expressions. The domain of the first function is from 0 to 2. Domain of the second function is from 0 to 10. We need to first express f of x in this form, in this completed square form, where a, b, and c are constants. Okay, so in the first part, we just have to use completing square method. Okay, now we did 2 methods for that. You can do whichever of them you prefer. F of x equals 2x squared minus 8x plus 10. Okay, we need to convert it to completed square form. Let's do that. Let's write the domain of the function as well. It's from 0 to 2 with both of them included. Now, how do you complete the square of this function? You first need to take 2 common outside. Okay, let's take 2 common. What does that leave you with inside? X squared minus 4x, and then leave some space. You have 510. Okay, so this is what we've got. Now you divide 4 by 2. What does that give you? 2. Add 2 squared and also subtract 2 squared, and that will give you a perfect square. From the first 3 terms, you have x minus 2 whole squared. That becomes 2 into x minus 2 whole squared minus 4 plus 5. Remember, this whole thing is inside bracket for now. 2 is common outside. That's going to get multiplied at the end with each of those terms inside. We have 2 into x minus 2 whole squared plus 1. Now you multiply that 2 outside inside the bracket. So it becomes 2 into x minus 2 whole squared plus 2. That is what the completed square form of this function turns out to be. 2 into x minus 2 whole squared plus 2. Okay. Now it says, state the range of f. State the range of f. Now let's think about this. It's a quadratic function. Remember, for quadratic functions, you always should think of this using the graph of the function. So think about what the graph of this quadratic function looks like, and then decide based on that what the lowest point on the graph is, what the highest point on the graph is. It's a quadratic function. The coefficient of x squared is positive. That means it's a U-shaped graph. So it's going to look like this. This is going to be the shape of the graph. Okay, with this as the turning point. Now, what's the turning point? Can you figure out the turning point from this completed square form? 2 and 2. The x and y coordinates, both are 2. Remember what the standard form used to be. A into x minus h whole square plus k. H is 2 and k is 2. Both of them are 2. Now, if that does not look very familiar to you, that means you're forgetting what we did at the start of the course. So make sure to revise. We did this in quadratics. A into x minus h whole square plus k. This is the standard complete square form. What's the turning point from that? The turning point is 2 and 2. That's the turning point. Okay, so we always have to think of the turning point of the quadratic function when we're looking for the range of the function. So this is the turning point. Now, which part of this function is valid? It says x is between 0 and 2. Okay, so one extreme is this 2, and the other extreme would be somewhere on the left side because the x coordinate is 0. So on the x-axis, it's going from 0 to 2. That's what the function is going. That's what the function is. That's where the function is valid, between 0 and 2. And now what the function is, let me write that down here. Function was 2x squared minus 8x plus 10. Now we need to figure out what the value of this function is when x equals 0. What's f of 0? Let's figure that out. F of 0, if you were to input 0 inside this, the y value would turn out to be 10. So when x is equal to 0, the y value is 10. Now vertically, what's the range of this function? Now, this is not that complicated in this particular problem, although the examples that we did earlier, we looked at them, how we could have something more complicated than this. In this case, the range is just 2 to 10. So how do you write the range then? You would say the range of the function, you should always use y here. You would say y is between 2 and 10. Okay, y is between 2 and 10. The domain of the function was from 0 to 2. 0 and 2 both were included. 0 and 2 both were included. So here as well, 2 and 10 both are included. That's the range of the function. If you wanted, you could also write it as f of x between 2 and 10. That could also be fine. Or you can just use y between 2 and 10. Don't write x here. That will not be acceptable. Okay, so that's the range of the function. Range of the function. That's the second part. That's what we have to do here. Now, what about the third part? Now it says state the domain of f inverse. Domain of f inverse. Now, generally, they ask us to find range of functions. Now, they're asking us to find domain of f inverse instead. How can we do that? How can you find range of domain of f inverse? Any idea?
Range of f or
we talked about this in the last class, and I just revised that as well. Domain of the original function is the range of the inverse function. Range of the original function is the domain of the inverse function. What are we looking for? We're looking for the domain of the inverse function. So what we can say is the range of f of x, that should be the same as the domain of f inverse of x. Now, what was the range of f of x? We just found that here. It was y between 2 and 10. So what's the range of f inverse then? Sorry, what's the domain of f inverse then? Domain of f inverse is from 2 to 10 as well, but here, make sure that you're using x. It's a very common mistake to write y here as well, and that will not earn you that 1 mark. You will lose the mark if you use y there. Okay, so you have to make sure that you're using x here. X is between 2 and 10. That's the domain of f inverse. All right. This is the result. This is part 3. Now let's look at part 4. It says sketch on the same diagram the graphs of f of x, y equals f of x, y equals g of x, and y equals f inverse of x, making clear the relationship between the graphs. Okay, so we have to draw 3 graphs here. F of x, that's this quadratic function. Then you have g of x. G of x equals x. What's that? That's basically y equals x. That's that slanted line, 45-degree line, y equals x. And we said we have to draw that anyway when we're drawing inverse functions, because that shows you the line of reflection. That's the line of reflection. And then you also have to draw f inverse of x. You found f inverse of x here already. Where was that? Have we found f inverse? No, we haven't found it. So, okay, so we're actually asked to find f inverse in the last part. Okay, so we don't have f inverse yet. And we are asked to sketch the graph of f inverse before we actually have to find the function for f inverse. Now, how can we do that? We don't even know the function. How can you sketch the graph? Remember what we discussed in the last session? The coordinates of f of x and f inverse of x, they interchange. That's exactly how we drew this f inverse graph in the last session as well. On f of x, we had 1.12. We said on f inverse, it should be 2, 1. On f of x, we had 0, minus 2. On f inverse, we said it should be minus 2, 0. So you basically just interchange the coordinates. All right, and then you can draw the graph. Now, let's see how it's going to work in this case. Just give me a minute, I'm sorry. Okay, let's see how it's going to work in this case. F of x, g of x, and f inverse of x. Let me draw x and y axis here like this first. This is what it might look like. Actually, it's smaller. This is the y-axis. This is the x-axis. Now, what are the functions? Let me write those functions here. One function is f of x, and f of x is 2x squared minus 8x plus 10. And the domain of the function is from 0 to 2. Now, keep in mind, you should only draw the graph for the domain that is given. You should not draw it outside the domain. It should only be from 0 to 2. Okay. What about g of x? G of x equals x, and what's the domain of that function? Domain of g of x is from 0 to 10. All right, so we are only going to draw the graph on the right part here, f of x and g of x. So this is 0. Now on the horizontal axis, we need to go up to 10. So let's say this is 10, and we have 5 in the middle here, maybe 2, 4, and 6. That's not very good. Okay. So what we'll do is we'll take equal scale here. Let's say this is 2, this is 2, and then this is 4, 6, 8, and 10. Okay, this is what we have on the horizontal axis. Remember, when you're drawing graph of a function along with its inverse, you have to make sure you're using the same scale on both axes. So this much is 2 units. It should be approximately the same on the vertical axis as well. Otherwise, your reflection is not going to look good. And you might lose marks for that. So you have 2, 4, 6, 8 here. Let's sketch this graph. Similarly, on the negative side, you have -2, -4 here. We might not actually need them, but let's just mark them here, -2, -4. Okay, now what's the y equals x line? G of x equals x from 0 to 10. It's a straight line, right? So you can mark a couple of points. 0, 0, right? For this, when x is 0, y is 0. And when x is 10, y is 10. So we have another point here. You can just join these points. This is a graph of g of x. Okay, that's the y equals x line. Then what about f of x? F of x is a quadratic function. We know where the turning point of this graph is. We found that above. The turning point of the graph is 2, 2. Okay, let's mark that point, 2 and 2. That's going to be here. This is 2, 2. You only have to draw this f of x graph from x equals 0 to x equals 2. Okay, so you have 1.2 here, and you know it's the turning point of the graph. It's the lowest point it's the minimum point of the graph. You can see what happens when x equals 0. When x equals 0, the y value is 10, right? So you have another point here on the vertical axis. You will not get a graph paper for this, by the way. You'll need to sketch it on in some blank space. All right, you'll not have lined paper there as well. It will just be blank space. You'll have to draw these axes and label the axes properly like this, making sure you have the same scale on both axes. This is 10. Let's mark this other point. This is going to be here, 10. So what does the graph look like now? We know it's a U-shaped graph, and the graph that we have here, it's only the left side of the turning point. And it's only the left side of the turning point, only this part is valid. Okay, so what does it look like then? The graph is going to be something like this. Okay, this is what the graph would look like roughly. So at 2, it should look like a turning point, as in the gradient of the graph should be becoming 0 close to 2, close to this point 2, 2. So like this, okay? It should look like it's becoming 0. It's still not good enough. You should always do it with a pencil so you can erase it and make it better. So something like this, you can say. And so on the right side, it would have looked like this, but since we don't have to draw that part, we just leave it this way. This is f of x, all right? And now we have to draw the graph of f inverse of x. We don't even know what that function is, but do we have some points? We have taken 2 points for f of x. This point is 2 and 2. And the other point that I took above is 0, 10. Now, what about the inverse function? Where is point 2, 2 going to go? Interchange the coordinates. That would still be 2, 2. So you have 1 point here. 0, 10, where does that go? 10, 0. That's going to be here. So the other graph is going to be in this region. And what does that look like now? It has to be a reflection of that part. So keep that in mind as well. It would look something like this. So at this point, the gradient of this f of x graph was 0. For the inverse graph, when you make a reflection, the gradient would look like it's undefined at that point, and the graph would look something like this. This is the graph of f inverse of x, reflection of that using these 2 points. Any confusion with this?
Sir,
Yes?
sir, from where did you get 10?
Input x in this function, what do you get? 10. Y value is 10.
Sir, then why didn't you put 0? I mean 2.
You can try that. You can input 2. That gives you 2. We already knew this because we had this form here, and from this form we got that the turning point is 2, 2. So it was obvious that 2 and 2 lie, this point 2, 2 lies on the function. So we did not really evaluate it as such. But if you want to do that again, you can do that. Put 2 inside this function. You should get 2 from that. All right.
Okay, sir.
Okay. All right. So these are the 2 graphs that we have. In fact, 3 graphs that we have: f of x, f inverse of x, and g of x. Now the question says, making clear the relationship between the graphs. Now, what's the relationship between these 3 graphs? You're going to write that here. You would say f of x and g of x, sorry, f inverse of x, are reflection of each other in the line y equals x, which is basically g of x. Or you can say the reflections of each other in g of x. Okay. Or you can say g of x is the line of reflection of f of x and f inverse of x. That could be another way of writing that. That g of x is the line of reflection of f of x and f inverse of x. Okay, that's the relationship between these 3 graphs. Okay, so that's the 4th part of this question. Now it says, find an expression for f inverse of x. So now we have that function f of x. Let me write that down here. F of x is 2x squared minus 8x plus 10. How do you find inverse of this function? Remember, the first thing you have to do is you have to complete the square. Okay. Now, what's the completed square form? You've already done that in the first part. If you had not done that in the first part, you would have to do that anyway in the 4th part, and the 5th part, and the last part. But in this case, you've done it already. So you just use that result from the first part, and you would say f of x could be written as 2 into x minus 2 whole squared plus 2. Now, You say let y equals f of x. Now you could do this before as well, or do it afterwards. It doesn't really make any difference. So now y equals f of x, you would say y equals 2 into x minus 2 whole squared plus 2. Remember the domain of the function. Domain of the function is from 0 to 2. Now you make x the subject. How do you do that? You have 2 into x minus 2 whole squared. Take this to the other side, and that will give you y minus 2. I've just interchanged the left side and the right side. I've written this thing on the left, this on the right. Doesn't make any difference, right? Now, let's divide 2 on the other side. That will give us x minus 2 whole squared equals y minus 2 over 2. Now we take square root. But remember, whenever we take square root, we have to put plus minus. So plus minus square root of y minus 2 over 2. Now this 2 goes to the other side and gives us x equal to 2 plus minus square root of y minus 2 divided by 2. Now, once you have made x the subject, before you do anything else, now you have to decide whether to use plus here or minus here. It has to be only one of the two. Otherwise, it would not be a function and not acceptable. So should we use plus here or minus here? How do we decide that? We decide that using the interval for x that we're given, the domain for x that we're given. The question says, x is supposed to be between 0 and 2. Now, how can you get a value of x that is between 0 and 2? Should you add something to 2 or subtract from something from 2? 2 plus something will give you something that's greater than 2. And that's not what you want. 2 minus something will give you something that's less than 2. And that is what we want. You can only get some value within this interval with a minus sign here. You can't get a value within this interval with the plus sign. So we choose the minus sign in this case. And that gives us x equals 2 minus square root of y minus 2 over 2. Now you interchange interchange the variables and write down the inverse function. You would say f inverse of x equals 2 minus square root of x minus 2 divided by 2. And that's the inverse function. Now, there's a very common error here that people do while writing this result at the end. If you write it like this, 2 minus square root of x minus 2 over 2, that is not acceptable. Now, while you're doing the exam in a flow, a lot of times what you do is you don't make it clear that the square root is in both numerator and denominator. So it should be very clear that the square root is applying both on the numerator and the denominator. If you just write the square root like this basically says that the square root is only on the numerator and not on the denominator. So it should be very obvious from your writing that the square root is on that whole fraction, okay? And that's the inverse function. That is what we were looking for. Make sense? Any questions on this? Any problems, anyone? No problems? Sure. Okay, good. Now let's look at another question before we end for today. Which one was this, by the way? Was it 12? I'm sorry, it was 26. I'll just correct that. This was question number 26. Okay, let's have a look at another one now. Now, after today, you should be able to do a number of questions from the first row of assigned questions, not all of them yet, but many of them. You should try them. After tomorrow, you should be able to do all of them. Okay, except the trigonometric functions, we will be doing them as well during the next week, I think. I just want to look at one question in which they ask you about greatest value of something or smallest value of something. Yeah, this one. Question number 10 from the worksheet. Okay, I might not be able to complete this, or in this case, in fact, it doesn't involve a sketch, so it should not take that long. Let's do this very quickly. Question number 10 from the worksheet. Let's quickly do this, and then we end for today. Tomorrow, we'll talk about composite functions. Okay, so it says the function f is defined by f of x equals 2x squared minus 8x plus 11, where x is a real number. Okay. Now, first of all, we have to complete the square. Let's do that very quickly. So this is going to give us f of x equals 2x squared minus 8x plus 11. And the domain of this function is all real values. How do you complete the square? Take 2 common outside. And that leaves you with x squared minus 4x, leave some space, and you have 11 over 2. Now you could keep 11 outside the bracket as well, as in don't take anything common from that. That's also fine. That will also work. Or you can take 2 common from 11 as well. In that case, you'll have 11 over 2 left here. Okay. All right. Now you add 2 squared and you subtract 2 squared. These 3 terms give you a perfect square, x minus 2 whole squared. This is a perfect square. And that gives you 2 into x minus 2 whole squared minus 4 plus 11 over 2. Okay, now let's simplify this. This gives you x minus 2 whole squared minus 4 plus 11 over 2. What's that? Minus 8 plus 11. That should be 3 over 2. Now multiply that 2 inside, and that will leave you with 2 into x minus 2 whole squared plus 3. That is the completed square form of this function. Okay, that's the first part. We just try to complete the square. Okay. I hope that makes sense. That was pretty straightforward. Now it says state the range of f. Range of f, it's a quadratic function. We need to find the range of f. Now we have to think of the graph of the function. It's a U-shaped graph. The coefficient of x squared is positive. It's a U-shaped graph. It's going to look like this. Which part of this function is valid? Well, the whole function, because it says x is any real value. That's what the domain of the function is. X could be any real value. So this whole function is valid. So what's the range then? We just look for the turning point. What's the turning point of this function? You can find the turning point from this. 2 and 3, that's the turning point, right? This is the turning point. So what's the range then? On the vertical axis, the lowest point is 3, right? The y coordinate of the lowest point is 3. So your function, your curve could be anywhere above that point. So what's the range then? You would say the range of the function is y greater than or equal to 3. That's your final result. Okay. All right, let's look at the next part now. Part 3. Explain why f does not have an inverse. Now it's a quadratic function, and they're saying all of this is valid because it says x could be any real number. Why does it not have an inverse? Because it's not a one-to-one function. That's all that you've got to write there. Now, you can think of it why it's not a one-to-one function, because it fails that horizontal line test. You can draw this horizontal line that cuts the graph at 2 points. If you can draw any one horizontal line that cuts the graph at 2 points, that means it's not one-to-one. So this is not one-to-one because at these 2 points, we have 2 different values of x that are giving us the same value of y. So it's not one-to-one. Now, all you have to write here is, you would say f does not have an inverse because it's not a one-to-one function. That's all that you have to write there. Okay, you don't necessarily need to refer to horizontal line test and how that's failing. That's for your own understanding. the final result, the statement that you have to write is just this, that this is not a one-to-one function. That is why it does not have an inverse. Okay, part 4 now. Now there's another function g that's defined by g of x equals this, and we're given that x is less than or equal to a, where a is a constant. State the largest value of a for which g has an inverse. Now, what does that mean? What's this function g of x? Well, if you look at this closely, it's 2x squared minus 8x plus 11, and that's exactly what f of x was as well. What's the difference between these two? Why is this a different function? Because the domains of these two functions are different. Domain of f of x was all real numbers. Domain of g of x is x less than or equal to a, where we do not know what the value of a is. Let me write that down here. So they're saying g of x now is 2x squared minus 8x plus 11, and x is less than or equal to a. That's the function g of x. And now they say, state the largest value of a for which g has an inverse. State the largest value of a for which g has an inverse. Now, how do you think of this? So g should have an inverse. Now, when can g have an inverse? When can any function have an inverse? For a function to have an inverse, it should be a one-to-one function. So they are basically asking us, what's the largest value of a for which g would be a one-to-one function? That is what they're basically asking for. Now let's think about this. It's again that same curve, right? The expression is the same, so it's the same curve. The curve looks like this, U-shaped graph like this. The turning point of this graph is 2, 3. We have found that already, 2, 3. Now, what's the domain of this function? X less than or equal to a. Now, a is some value of x. So if the x-axis looked like this, let's say, this is the x-axis, let's say, okay? Now, if a was here, let's say this was a, and x was less than or equal to a, that would mean all of this part of this curve would be valid, right? X less than or equal to a, in that case, would mean this whole part of the curve would be valid. Is this one-to-one? This yellow part? This is not one-to-one, because you can draw this horizontal line here in the yellow part that will cut the graph at 2 points. So it's not one-to-one. If, on the other hand, a was here, and we had x less than or equal to a, that means this part. In that case, this part of the function would be valid. Is this one-to-one? Yes, this is one. This is one-to-one. So this could be one possible value of a, because for this value of a, it is a one-to-one function. Now, what we are looking for is the largest possible value of a for which this function would remain a one-to-one function. And it says x less than or equal to a. That means some part on the left of the function is valid. So we can consider the part to the left side of the turning point and see, okay, does it remain a one-to-one function or not? If a was, let's say, here, it is still a one-to-one function. Until this point, it's a one-to-one function. We can go a bit further. If a was here, it's still one-to-one. If a was here, it's still one-to-one. We can keep going on until we reach this turning point. And the value of a here would be 2. At this point, we have basically reached our limit. Because if we were to go even slightly to the right after this, the function would not remain one-to-one because it would fail that horizontal line test. So the extreme value on the right side that we can have here, the maximum, the highest possible value of a that we can have here is 2 for the function to remain 1-to-1. So what were they looking for? They were asking for the largest value of a for which G has an inverse. So the largest possible value of a could be 2. That could be the largest possible value of a. It could be anything less than that, and the function would still be 1-to-1. For example, you could have x less than equal to 1 here. It would still be 1-to-1. You could have x less than equal to -2. It would still be 1-to-1. X less than equal to -5. It would still be 1-to-1. X less than equal to 2, that would still be 1-to-1. But if it was less than equal to 2.5, for instance, then it would not be 1-to-1. So what's the largest possible value that we can have here in place of a? The largest possible value is 2. That's what we write here. We say the largest possible a is 2. Make sense? Now, sometimes they will give you a domain like this instead. You'll find such problems as well. So they might give you that the domain is x greater than equal to b. And in that case, they will ask you for the least value of b. So that means in this case, the right side of the function would be valid. The right part of the curve would be valid. So you can look at the right side. Okay, this is 1-to-1. This is 1-to-1. This is 1-to-1. What's the least value of b you can have? That would also be 2 in that case. So generally, when they ask you for the largest value of x or the smallest value of x such that a function remains 1-to-1, generally that value of x is going to be the x coordinate of the turning point. And that's the logic of this. So now when you get such questions, you can just write the x coordinate of the turning point directly, but this is the logic behind all of that. Is that okay? Any question on this?
No, sir.
Okay. All right, let's look at the last part and then we end for today. So the last part says, when a has this value, that means when a has this largest value that we found in the previous part, when a has this value, obtain an expression for G inverse of x and state the range of G inverse. Okay, let's do this quickly now. So we have g of x, the function g of x is equal to 2x² minus 8x plus 11. This is g of x. What's the domain of this function? They're basically saying now use the domain that you found in the previous part. You say the domain is x less than or equal to 2. We need to find the inverse of this function. Now, how do we do that? You first have to complete the square. Now, they have made us complete the square of this expression already in the first part. And that's this, 2 into x minus 2 whole squared plus 3. Let's just use that. 2 into x minus 2 whole squared plus 3. Now, let y equals f of x. Or sorry, g of x. What does this become? Y equals 2 into x minus 2 whole squared plus 3. Take everything to one side. Apart from x minus 2 whole squared, it's going to become y minus 3 and then divide by 2. Take square root on both sides, but remember, whenever you take square root, you have to put plus minus. And then inside square root, you have this whole thing, y minus 3 over 2. Then 2 goes to the other side, and you have 2 plus minus square root of y minus 3 divided by 2. And now what's the domain of the function given? The domain of this function is x less than or equal to 2. So now you need to decide between plus and minus. If x is supposed to be less than or equal to 2, do we have to add something to 2 or subtract something from 2? We will have to subtract something. 2 minus something will give us a value that's less than 2. So what do we choose from here? Minus. So it becomes x equals 2 minus square root of y minus 3 over 2. And then you can write down the final inverse function. You'd say g inverse of x, therefore, is equal to 2 minus square root of x minus 3 divided by 2. That is g inverse of x. Okay. Now, in all three examples that we have done for this, we had negative sign. It does not mean that we always have negative, just like we don't always have positive. It will depend on every single question. We'll have to think of the thing using the domain of the function, whether you should put plus there or minus there. Okay. All right, let's have a look at the second thing that they are asking here. State the range of G inverse. What's the range of G inverse? The range of the inverse function is the same as the domain of the original function. So what's the domain of the original function? Domain of G of X. That should give us the range of G inverse of X. Now we already know the domain of G of X, that was X less than equal to 2. So that means the range of G inverse of X should therefore be Y less than or equal to 2. You have to make sure that you're using Y here instead of X. That's the range. That's the second thing that they were asking for. You have the expression for G inverse of X and also the range of G inverse of X. Make sense? Any problems with this? Any questions?
Sir, instead of y less than or equal to 2, can I write inverse g of x less than or equal to 2?
No, not G of X. In this case, you would have to write G inverse of X less than equal to 2. And that will be okay.
Yeah. Okay.
Yeah, you can do that, yes. Okay, makes sense? Any problems with this?
No, sir.
Okay, so tomorrow then we are going to be doing composite functions. All right, composite functions. We'll discuss how to find composite functions and also how to find the domain of composite functions, range of composite functions. There are some properties that we need to know about those two things. That is what we will be discussing tomorrow, inshallah. All right, so that's it for today. I'll see you again in the next class. Allah Hafiz. Okay, so those of you who are there on YouTube, by the way, I have this past paper session starting from 13th of April. The registration link for that is there in the description of this video, and it's also there in the live chat on the right side. I'll be doing yearly past papers, focusing on the last 4 years. We'll do as many as we can in the next month or so. If you are interested, the registration form is there. The link is there. You can have a look at all the details of the course in that form, in the registration form that you'll find at that link. All right. Let's see some of you there, inshallah. Okay. Allah Hafiz.